Earth science. Earth's oceans. 71% of Earth's surface is covered by ocean. This world ocean is huge, and it holds a wealth of scientific treasures. Because it's so vast, we still have so much to discover. It's amazing, but we know more about the surface of the moon than we know about the ocean floor. Let's look at what we do know about the physical aspects of the ocean. The oceans play a major role in moderating Earth's temperature and climate. Water has a high specific heat capacity. It absorbs thermal energy and holds on to it. It is slow to heat up, and it's slow to cool down. Water transfers this energy to its surroundings when it cools, and absorbs thermal energy from its surroundings when it warms. Because of water's high specific heat capacity, lands near to oceans have more moderate temperatures. An example of this is seen in the comparison of San Francisco, California, and Wichita, Kansas. Another example is the Gulf Stream. Warm equatorial water from the Caribbean flows northward, then eastward across the Atlantic, and as it travels, it transfers heat to the westward moving air, which influences weather and climate in Great Britain and Europe. The Gulf Stream is like a huge heat reservoir. We mentioned currents. Ocean water moves in currents. How do ocean currents form? The driving force for both air and ocean currents is the unequal heating of Earth's surface. Earth's surface temperature depends on the amount of energy it receives from the sun, and the amount varies depending on the angle at which the sun's rays strike Earth's surface. It is like the example of the flashlight. When the flashlight is held vertically, the light beam strikes the surface directly, and the light is concentrated. But when the flashlight is held at an angle, the light spreads over the surface. It is less intense. In equatorial regions, the sun's rays strike Earth's surface directly, so solar energy is concentrated, and equatorial regions are warm. At higher latitudes, the sun's rays strike Earth's surface at an angle, so the same amount of solar radiation is spread over a larger area. Solar energy is dispersed, making these regions more cool. Energy flow is from high to low, from warm to cool, and solar energy is the driving force. That brings us to the two types of ocean currents: wind-driven surface currents and density-driven deep currents. Water in the surface zone moves vertically in response to temperature and density, and horizontally in response to wind. And water in the deep zone is density-driven and circulates from cold polar regions to warmer equatorial regions. Density is a common factor in driving both surface and deep water currents. And the density of seawater is controlled by two factors: temperature and salinity. Let's talk about temperature. It makes sense that water at high latitudes is cold, and because cold water is denser than warm water, it sinks, and this sets up the movement of deep water flow. What about surface currents? Wind drives the surface currents. What about salinity? The saltier the seawater, the denser the seawater. Salinity is influenced by factors that increase or decrease supplies of fresh water. Salinity decreases as fresh water enters the ocean. Runoff from streams and rivers, precipitation, and the melting of glacial and sea ice. Salinity increases when fresh water leaves the ocean, through evaporation and the formation of sea ice. Evaporation increases salinity because only pure water leaves the seawater solution. The salts are left behind. And when sea ice forms, only the water molecules freeze. Salts are left behind in solution. The ocean's salinity is balanced when evaporation is offset by precipitation and runoff, and when ice formation is offset by ice melting. So deep ocean water circulation begins in the North Atlantic as dense, cold, salty seawater sinks and flows along the ocean bottom toward the equator to the Antarctic Ocean, then eastward and again northward in an overall north to south circulation pattern. and surface currents driven by the wind, which are driven by the unequal heating of Earth's surface. What else about the ocean? What do we know about the ocean's topography? The ocean floor consists of continental margins, deep ocean basins, mid-ocean ridges, and deep trenches. The continental margin marks the boundary between the continents and the ocean. It consists of the continental shelf, the continental slope, and the continental rise. The continental shelf is a gently sloping underwater surface extending from the shoreline toward the ocean basin. It is an underwater extension of the continental crust. When sea level changes, the extent of the continental shelf changes. When sea level is low, such as during a period of glaciation, the exposed or the above water continental shelf is wide. Less of the continental edge is submerged. When sea level is higher, as when ice caps and sea ice melt, the exposed continental shelf narrows. More of the continental edge is submerged. The continental slope marks the boundary between continental crust and oceanic crust. And the continental rise is the transition zone between the continental margin and the deep ocean floor. Then we have the deep ocean basins, which are generally about 3 to 5 kilometers deep. Here we have the abyssal plains, some of the deepest and flattest regions on Earth, and a variety of volcanic peaks, seamounts, and small abyssal hills. The abyssal plains end where the mid-ocean ridge begins. The mid-ocean ridges form a continuous underwater volcanic mountain chain extending throughout all the oceans. This is the zone of seafloor spreading, where oceanic crust is made. In ocean basins that border convergent plate boundaries, ocean trenches mark the deepest places on Earth. They occur at subduction zones, where lithospheres force down into the asthenosphere. This is a major earthquake zone, some being quite large, and an area of violent volcanic eruptions. The ocean is an immense body of salty water. It formed in the Archean, and it's where life began. In fact, there are life forms in the ocean that are still undiscovered. The ocean is vast and deep, with a varied topography of flat plains, high peaks, and very deep ocean trenches. There is so much we do not know about its treasures. The oceans, as a body of water, are a treasure in itself. Throughout time, the oceans have influenced our climate. The ocean's ability to store and release heat make it a pivot point in the stability of Earth's climate. Question. We talked a bit about the continental shelf. What is a possible consequence to life forms living on the continental shelf when sea level rises? How about when it lowers? Onward.